Episode 256 of CppCast with guest Bruno Cardoso Lopes, recorded July 16th, 2020. This episode of CppCast is sponsored by Clang Power Tools, the open source Visual Studio extension on a mission to bring Clang LLVM magic to C++ developers on Windows. Increase your productivity and automatically modernize your code now. Get ahead of bugs by using LLVM static analyzers and CPP core guidelines checks from the comfort of your IDE. Start today at clangpowertools.com. In this episode, we discuss CppCon going virtual this year. Then we talk to Bruno Cardoso Lopes from Facebook. He tells us about his work on Clang and much more. Welcome to episode 256 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm okay, Rob. How are you doing?
Doing okay. Little pandemic update. We are planning on sending our kids to the online school option for next year. So I say send, but they'll be staying here for the next year. There's options to either, do part-time schooling or do fully virtual online. So we just think the virtual online is going to be safer with the way things are going.
Interesting that your school district is giving you all those options. I don't honestly know what's happening here because I don't have kids.
Sure. It seems like that could still change. Like some of the other counties nearby have announced they're going to go fully virtual. But as of now, our school is still giving you the option.
Interesting.
Yeah. Well, at the top of the episode, I'd like to read a piece of feedback. This week, we got a comment on Reddit about last week's episode from Spirited Being saying, really interesting episode. Makes me want to complete the other books in the Ray Tracing in One Weekend series. Have we talked about that before? Ray Tracing in One Weekend? That sounds interesting.
I believe some guests from time to time may have mentioned it.
Okay.
But I do know that it's come up several times in my meetup. So honestly, now I don't remember from where I've gotten the most exposure to it.
Okay. We'll have to find a link for it and put that in the show notes. All right. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Bruno Cardoso Lopes. Bruno has been contributing to Clang and LLVM-related technologies for the past decade, spending the last 4 years on the Clang front end. He's passionate about C++ and joined the C++ Standards Committee in 2017. Bruno currently works for Facebook. Welcome to the show.
Thank you. Thank you guys for inviting. Very nice to be here.
Thanks for coming on.
All right, so Bruno, we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about your work on Clang and compilers, okay?
Okay.
All right, so this first one we have is an update to Mesonbuild, and we had him on earlier this year, right, to talk about the latest with Meson. So what's new in this update, Jason?
Mostly I just wanted to call it the fact that it is still an active development. There's still a lot of stuff going on. But G-test specific support and that was the main thing that jumped out at me. But lots and lots of small fixes and updates. So clearly this, build system is still an active development.
Yeah, it's a pretty long changelog. The G-test definitely sticks out. He's also added ability to specify targets if you want to just compile a single target, I guess. You can do that now, as opposed to building the entire project. Yeah.
So I must admit, I still have not actually used Meson myself. Any chance you have, Bruno?
I haven't, but I found it really cool that now you can specify targets, because at least for Clang development and things like that, it's pretty handful not to have to build everything all the time.
Right.
Be specific with their targets. And I also found cool that now they have this... they can use LLVM Cov to generate coverage information, kind of automatically, sounds like. It's pretty cool.
That sounds really helpful, yeah.
Yeah. Okay, next thing we have is this YouTube video that I saw on Reddit, and it's writing an LLVM optimization, and it's, I think, like an hour and a half long video. I did not watch the whole thing, but I don't see much about tutorials on how to get started in LLVM, so I thought this seemed like it could be a valuable resource.
From my perspective, it definitely seemed very. It was done like a course, like, introduction, how to build LLVM, like all of the details, all of the function calls and the types and the stuff that you're going to interact with. And it's very rigorously done, I thought. But I don't have a lot of in-depth experience with LLVM, so it's possible that some of it's wrong and I just didn't, see it.
Yeah, do you have any thoughts on this one, Bruno? As someone who does work on LLVM?
First thing, I thought it was using a pretty cool hat. And I like the references for IR instructions and other tables he put on the slides. It was pretty cool as well. And I think the example that he chose, which was about like float point comparison, to kind of apply his optimization on top, I think that was an interesting choice, because it's usually like whatever guide it is, it's exploring, I don't know, some more kind of canonical or simple things to do. Not that this is complex, but I like the choice. I thought it was a cool choice for a video.
Awesome.
Yeah. Okay. And then the last news thing to discuss is CppCon's announcement that CppCon 2020 will be going virtual, just like the CPP on C conference, which I think is this week, right, Jason?
That sounds right. Yeah. So I lost track.
Yeah.
I've had a lot going on this past week, so.
Yeah, definitely.
Oh, yeah, it's right now.
Yeah. The CppCon will be virtual. Tickets are now on sale, and it's at a much reduced price because it will be virtual. I think it's $200 for early bird tickets.
Yeah,
and that's available until August 5th. Yeah. They're going to be keeping the same time of day based on Colorado time is when they'll be doing the virtual sessions, and it will still be multi-track. They haven't announced what they're going to be using as far as software to host the conference, or what website it'll be on or anything like that. But they're investigating different tools. Maybe they'll use the same thing that CP on C uses. Anything else to say about this, Jason?
Well, I think for just our listeners who haven't been necessarily following along with all this, CppCon was waiting as late as possible to see what their options were to try to be still at least partially in person. So the big news, and this is just of 3 days ago, that there will be no in-person portion at all. It's 100% online. I've seen some interesting feedback from people who are at C++ on C right now about how this kind of virtual conference environment, like we were talking about last week, is actually pretty cool, and you can like wander around and chat with people and stuff in it. Nice. So yeah, we'll see how it goes.
I am wondering, is there going to be a lot more room for people to join the conference who maybe otherwise wouldn't have, just because that price point is so much lower, barrier to entry is so much lower. I'm not sure if they're putting any type of limit as to how many people can sign up.
Yeah, I don't know either, obviously. I have one person told me that they're like, how can I get my company to pay for me to go to a conference when we know that's just virtual, when we know a week later all the videos will be on YouTube anyhow?
Yeah, that's an interesting point. I mean, they're going to have this online software to try to capture the hallway track. You'll be able to ask questions directly of the speakers. So there certainly is, still going to be benefit to buying a ticket. But I understand that concern with trying to get your company to pay for it.
And I have no idea. I am planning to buy a ticket, which might sound funny, but at the moment, I'm not giving any talks or teaching any classes at the conference. So it'll be a different experience for me.
Yeah, I plan to do so as well. How about you, Bruno? Are you planning on virtually attending this one?
So I haven't thought about that yet, but sounds like it's going to be, I like the trend of like keeping things virtual. That's a good thing. The session hours were pretty reasonably scheduled across the different time zones, and that was very interesting as well. But let's see. Yeah, I'm definitely interested in that.
Yeah, that's a good point. Even for Central European time, it's 4 p.m. to 10 p.m., which isn't maybe ideal, but also not terrible.
Yeah.
Of course, our Oceania friends will, as always, they're the ones that get left out when we try to schedule things for as much of the world as we can. But sorry, New Zealand and Australia, you're just going to have to watch it online.
Yeah. All right. So, Bruno, could we start and talk a little bit more about how you got involved with working on compilers in the first place?
Sure. So I had this colleague back in school, kept talking about LLVM. This was like 2007. There's this new awesome compiler technology, etc. And I was still an undergrad student, and I was looking for like things I could do on LLVM that were not already taken at the time. Luckily, since this is like a decade ago, there were like a few things available. In this specific case, I was like very interested in backends, and I noticed that the MIPS backend was something that was not yet done for LLVM. So I started looking around and like cook up a skeleton patch and send out to the mailing list, and also send a proposal. That the timing was good because they were doing Google Summer of Code at that point already. So I think that kind of helped me get through the process because I already had a patch, and then I started working on it as part of Google Summer of Code. That's how I first that's how I started my kind of compiler journey. And it was actually my first like meaningful use of C++. That's when I saw a bunch of things I've never seen before, and I was pretty amazed with all the things you could do, etc.
I'm curious, why MIPS? Why did that catch your attention?
Because there was already like an ARM backend, and x86 already existed. But Spark already was a thing there too. So I guess MIPS was the natural next choice, since at the time there was already like EMU support and other things I could use for developing and testing it pretty easily. And it was cool. Like I was able also to get a MIPS multiboard that at the time I got like someone from Sony gave me. And they shipped to me, and then I used some of that as well to test that the backend was working and everything.
Okay.
And also because it was an example of a RISC architecture that is like pretty simple, and that sounded like a good scope for starting. Once you get into the real developing for MIPS things are a bit more complex than they seem, because MIPS has like a bunch of different ABIs, a bunch of different architecture revisions. So, but yeah, it was a nice way to start.
I've only ever worked with MIPS when I was writing some software that the organization I was working for wanted it to be ported to run on Linksys routers, Linksys routers that had already been hacked to run Linux. And so I just kind of was curious if that's was related at all, because it was about the same time frame you're talking about. Right.
One thing for sure that I remember when I look over like the same set of Linksys stuff you're mentioning, I remember seeing how they explored so they could update the BIOS or something like that. And I remember seeing like a MIPS assembly, and it was convenient at the time because it was like, oh, I can actually read this.
That's awesome.
So that's how you got started. What have you been working on in Clang more recently?
So more recently, I've been working on Clang modules. So for there's a difference between Clang modules and C++20 modules.
Okay.
So just for the people who don't know more about it, I'm going to do a short explanation. So Clang modules is basically what I call header modules, because it's basically the capability of building modules out of collections of headers. So the nice thing about packaging headers, in a way, packaging might not be the right word here, but like putting headers together and building that and putting them on disk and having that on a cache and being able to reuse that. This is basically how Clang modules work. It's an AST. You get the AST of all the headers that comprise the modules and put them in a cache. The good thing there is that you get very interesting build time speedups, because you don't have to reparse headers or anything like that. So it's very efficient for that kind of thing. You can see an average like a speed up from 15 to 20%. That's on build time. That's what I've usually seen when projects adopt that. Clang itself can compile compile with modules on. This is accomplished by like an extra file called module maps. So in the module map, you put the name of the module you want to have and lists inside that description all the headers that are part of it. If you compare to C++ modules, you still have some of that. When you see people talking about header units in C++ modules, that is basically what Clang modules is. So I've been working on that piece of technology for the past 3 or 4 years, and it's a very interesting process when people go adopt Clang modules, because it's not about only writing a module's description and the headers that are part of it. There's more also the part of like where you have to fix your headers so that they become something like the headers are standalone in a way, which means that they include whatever they use, that they do good practices, that you're not doing like X macros and things like that. Basically, they need to be somewhat well behaved. And when that's the case, you can easily transform then your piece of set of headers into a module. And that's the thing I've been working the latest.
How does that?
Years.
It sounds very similar to how precompiled headers work. Is that a fair comparison?
I would say yes, especially when you think about the disk representation. So because at least in Clang, the technology for PCHs and modules is basically the same. It's like you're serializing ASTs. The only difference here is that there's a bit less semantics involved, because the way that Clang modules work is that when you do a pound include a header name, Clang has extra logic to go look around that header and see if there's a module map file that responds for that header. Whereas when you're using PCHs, it's usually you have to pass a dash include in the command line pointing to the PCH you want to use. So in the beginning of your translation unit, you're going to have all the content from the PCH coming. Whereas in modules, you have fine-grained control, because you do pound include the name of the header, and you're going to get the visibility of the symbols of that specific set of things in that header or module. And if that specific header include or import other modules, you might be able to restrict what's coming in from that import. Doesn't mean that you're always transitively getting everything. So there's more of a fine-grained control there. PCHs are more brittle in that sense.
Right, yeah. For people who haven't used PCH, it's easy to break your build between non-PCH and PCH versions of the build if you have a header or don't have a header that you expect to have in place, right?
Right.
That's what I've observed.
And the same could happen, you can even mix modules and PCHs, and that could also be a big source of problems.
Okay. So is the plan moving forward for the modules that you've been working on to morph into the C++ 20 modules, or do you expect to maintain both sets of functionality?
I think we're going to have to maintain both functionality for a long time, especially because Clang modules work for C, works for Objective-C. It's not specific to C++.
Okay.
And there has been different vendors and folks around that are relying on Clang modules as well. So I expect it to live for a long time. Ideally, the core technology is the same if you think about how it's implemented in the compiler. There are differences, but it shares a lot of the things. So I expect it to still be there, because it won't be a huge burden also to maintain.
Did your work on the Clang modules have any impact on the ISO modules? I know you're a member of the ISO committee. Did you do any work on ISO modules?
Right. Yeah, I wrote a few papers back in 2018, I think. There were more towards having C++ standard module, having things from the Clang modules world, and things that would be nice to have, so that vendors that were relying on Clang modules could have like a path of adoption and things like that they could start with their headers maybe, and then slowly migrate to actually having like module implementation units and other like things that are more C++ like modules. Mm-hmm. So yeah, I try to contribute in that direction, to have some of the things that Clang modules had.
Okay. So when we were getting ready for this interview, I was looking at your LinkedIn page and I saw you've got some patents and stuff on there. And one of them really caught my eye. Which I cannot even pretend to pronounce the Portuguese. But the method and system for emulating instructions and executing legacy code. Is that a proper translation of this patent?
Yes.
Okay.
Yes.
It caught my eye. I have no idea what it's about. Is it something that you want to talk about?
Right. Sure. So this is the result of the work I did during my PhD, which is basically around the areas of like computer architecture and code compression. But it actually has the root in the compiler work. So one of the things I did in LLVM was in 2010, 2011, I implemented support for AVX. AVX is a multimedia instruction set that x86 has that came after SSE. Nowadays we have AVX2, AVX 512, and other things like that. And while writing that, like doing that support, I've noticed that instructions on AVX, they were bigger than regular x86 instructions. They introduced some new prefix headers and other things so that they could encode more information. And then I start like thinking about, well, what's going to happen in the future with the size of these instructions, right? Because it seems that it's growing and there's announcements of other things coming in the future. So I got really curious about that. And then I joined other researchers back in Brazil in the university I was studying. And we start looking at things around that because that sounded compelling. And at the time, x86 had like Atom, and they were talking about Quark as well. And those were basically like would be x86 stuff for low-end embedded, which means, and that kind of like goes hand to hand with the research we had back then, which was about code compression and how you could like compress code so it would run faster. The idea basically here is like if you have smaller code for the same amount of cache, you're going to have less cache misses. And if you're especially on a low-end embedded device, that's pretty good for performance. So we start looking into that, right? And then we noticed like, well, we did a bunch of static and dynamic analysis. Like we run, I don't know, like in virtual machines, Windows 95, Windows 98, old versions of Linux, a bunch of different OSs doing like basic tests, like open a spreadsheet or navigating the browser, a bunch of different things, just to catch the usage of and profile of those instructions to see more or less how things behave. And then we find out that most part of the instructions, there were a lot of instructions in the x86, like a byte or two that were never used and things like that. So, well, what if backward compatibility is very important for x86, but what if we re-encode this? Like, you know, like we can't, it's CISC is more complex to do something like RISC architectures do, like ARM has like thumb and MIPS had micro MIPS and etc. So we start exploring like, well, what if we re-encode some of this? What will be the fallouts of that? So we end up with this really complex like page table based annotation of versions for backward compatibility and OS based emulation. And the idea was that we would re-encode the most used instructions using smaller opcodes, especially picking opcodes that were not usually used over the years when we found in our analysis. So that whenever you would encounter those things, depending on the mode you were, how your executable has been annotated, you would then fall back to emulate in case you needed to emulate that instructions for like a previous version of the software or anything like that. So in general, it was a mechanism to like emulate whenever you need to emulate, but re-encode and have faster execution from when it was not the case.
I want to, if you don't mind, go back to, you said earlier, compressing the code. And to be clear, make sure I understand, you're not saying like compress like zlib, you're saying compress as in just make smaller code, like compile to a smaller representation of the same code?
Right, exactly. It's not on the zlib or anything really. It's more like the intrinsic the intrinsic representation of encoding and all of this, that kind of stuff.
And so is this directly related to the shrink research that you also did?
Exactly. Shrink was the funny name for the like academic purposes for the paper title.
I am
completely removed.
It is, I never stopped and think about it, but having you just explain that, it does sound highly likely that there's older x86 instructions that just simply aren't used anymore.
Right.
And out of curiosity, like, do you have some estimate, like what percentage of the possible x86 instructions are actually still in use or something like that?
That's a good question. I mean, this dates back to like 2010, 2011, so my memory is a bit fuzzy on that. But yeah, certainly like those, there are a few like, trying to remember here. I mean, I don't know about current usage, but at the time was like all those instructions for converting, what was the name again? ABC? What's that kind of representation?
BCD?
BCD, exactly. There's like bunch of instructions for that thing, and even on old machines or old OSs, it was not something that triggered a lot. Maybe we didn't try with the right software, so it didn't ever show up, but we didn't see much of those, for example. And they're very short.
That's a funny one for you to bring up, because I actually just did a Twitter poll asking if anyone in my Twitter network had used BCD instructions for anything. And for our listeners, that is binary coded to decimal. And it was a very low percentage of people who had said that they had actually used it. And almost every single one who responded said that they had used it when working on a 6502, either emulating it or writing software for it. And it came down to displaying the score in the game, basically. That's like what everyone had to say. Now, I know that big iron, like IBM stuff, it's still used in some financial systems, but otherwise it seems, it was not very much used.
Yeah, like I for sure never use it. How about you, Jason?
No, I've never used it. And for just a little bit of history here, Nintendo removed that portion from the 6502 and they put their sound code in the same place in the die. So Nintendo didn't, I think that's right. I'm pretty sure it's Nintendo's 6502 didn't have BCD instructions at all.
Wow. So the 6502, is that the Motorola series of processors?
That's, no, not Motorola. That's MOS. It was the chip that was used in the Nintendo, the BBC Micro, the Commodore 64, and then there's Ben Eater, I think is his name, who's doing a series of YouTube videos on programming 6502 from scratch right now, like building a computer from scratch at the moment.
Oh, that's pretty cool. Yeah, I was looking recently into like Genesis and Mega Drive, and I saw them they used the M68K. So I thought like the numbers were similar.
They're similar. Yeah, it was the 6502 was originally like binary compatible with the 6800, I believe. Okay. Yes, because just like, and then the Z80 and the X86 share a very similar instruction set as well from back in the day. Cool. Anyhow.
This is so over my head. Did the shrink research get put into use by any like CPU vendors or anything like that?
So not to my knowledge, actually. Okay. We presented that in several like venues at the time. Like got feedback from some CISC vendors that was pretty cool, but we don't see a lot of CISC machines around where this kind of technique would be profitable to be applied. And the ones that are currently in the market, like I don't see them following up with low-end embedded stuff as they used to. So maybe in the future the paradigm will shift again and they might have an opportunity, but no, not to my knowledge.
So you've mentioned the AVX instruction set a few times and you work in LLVM. It looks like you've done work specifically on implementing AVX stuff in LLVM.
Right. That's true.
What, and I see this, I saw a mention on your work to the TableGen thing, and bringing that back to the video that we were just talking about on implementing your own optimizer. That talks about TableGen as well. I don't have any idea what that's about, though.
So basically, TableGen is DSL, and it's using the compiler for a bunch of different things. So, for example, if you're writing backends, you use TableGen to describe your instructions, and not only the encoding of those instructions, but you can actually like create several layers of abstraction. You can like define an instruction format, and then you can write an instruction group based on a instruction format, and then you can actually go and describe the instruction. So it's very convenient for doing that kind of work. It's also capable of, there are TableGen representations for some of the LLVM-IR-ish kind of things. So you can further even describe a match between a target instructions and actually an LLVM instruction. So some of the code generation you can also write in TableGen. So it's kind of very, very powerful in that sense. And also you can write when you're trying to match things between the intermediate representation and the target. You can also write custom patterns in C++ and attach those things on the instruction you're declaring, so it can match kind of conditionally if it, meets some of the criteria you're writing code for. And you still have all the C++ logic and everything for writing your backend, but it's very handy to have the TableGen around for facilitating some of that description. And not only that, but like, for example, if you move to the front end, you're going to see that TableGen is also used for describing like language options, warnings, errors, and all things like that. So it's pretty flexible for basically everything that you have to write a lot of code to have, like generate tables and like do all the table search and match things. It's pretty convenient to have all that code. And of course, like TableGen is this DSL, and the compiler, quote, compiler for it's inside LLVM itself. So it's well targeted for LLVM or Clang things. But you could use it for anything like that. If you look at if you build LLVM and you go looking for .inc files in your build directory, you're gonna find like a bunch of tables and a bunch of code using those tables, and those are basically like C++ code that gets generated by TableGen.
Okay. So you said like the instruction sets are defined in TableGen as well, right?
Exactly.
Okay. Now, I just feel like I have to bring this full circle now. So, is the entire x86 instruction set defined in TableGen?
It is, yes.
Every possible instruction.
I mean, assuming that we're like, ideally, yes. I don't know how much complete it is in terms of like if you get AVX 512 or some other x86 thing that hasn't been described there yet, but potentially you can. Because in the worst case, you define a very shallow instruction, and then with real C++ code in the backend, you go and fulfill that gap. So you could, let's say you're trying to represent something on x86 that is really complex. You're just going to describe the easy part in TableGen and do the weightlifting later in C++.
Okay.
But you're going to at least have an entry for an instruction there.
Okay. Yeah.
That's also sorry.
No, please go ahead.
That's also because that is also going to be used for auto-generating parts of the disassembler and the assembler. So even if you're not code-generating, it's pretty useful to have around because it can also be used for all the other, even lower-level things.
I just found myself thinking, like, bringing this, like, all the way around and trying to imagine, like, how does the compiler pick what instruction to use in a given situation? And I'm like, well, if you were doing a BCD-like operation, would the compiler be able to find a BCD instruction that matched that?
Right. This is a good question. So it won't generate code using those BCD things. But if you open if you go look into TableGen, the instruction is probably there because it was useful for someone at some point while like trying to disassemble or assemble thing. Like if you're using the Clang integrated assembler to write assembly, you might want to use that instruction, and it should be there because of that kind of thing. So it won't be used for code generation, but it's going to be used for the other lower level tools.
Okay.
So there's a very high chance that it's there just because of that.
I feel like I should take just a second, since we just mentioned BCD like 12 times, to mention what it actually is. So that's, instead of, a typical byte can hold like, 0 through 15, or sorry, 0 through 255. Well, no. There's packed BCD and not. But anyhow, okay, so it uses 4 bits to represent the values 0 through 9. We don't ever, you can't go to 15 in those 4 bits. So that it's literally just encoding decimal in a binary representation. Then when you go to read those values back out, then you just have the decimal, and it's easy to convert it to ASCII to display, which is why it was used for scoring in video games back in the day. That's a very terrible explanation, but it's there for our listeners in the future.
That's pretty good, actually.
I want to interrupt the discussion for just a moment to bring you a word from our sponsors. Clang Power Tools is the open source Visual Studio extension on a mission to bring LLVM tools like Clang++, Clang Tidy, and Clang Format to C++ developers on Windows. Increase your productivity and modernize your C++ code with automatic code transformations powered by Clang Tidy. Find subtle latent bugs by using LLVM Static Analyzer and CPP Core Guidelines checks. Don't fiddle with command line switches or learn hundreds of compiler flags. Clang Power Tools comes with a powerful user interface to help you manage the complexity directly from the comfort of your IDE. Never miss a potential issue by integrating Clang Power Tools into your workflows with a configurable PowerShell script for CI/CD automation. Start experimenting on your code today. Check it out at clangpowertools.com. I wanted to talk about some of these other papers you worked on recently at the ISO committee. There was one about disabling static destructors, which I don't think we've mentioned before on the show. Could you tell us a little bit about that?
Yeah, so we've been hearing from especially game developers for a long time that they are the hell out annoyed about the fact of having to deal with this sort of initialization fiasco that we have in C++. Mm-hmm. And they've been wanting to have a way to say my program's never gonna end, theoretically, right?
Right.
So why do I need to care about those things? I mean, there's a lot of philosophical discussion behind that kind of stuff, but there are basically users that want that, and that was the idea of the paper. So the way we were going to convey that is through an attribute, like a no-destroy attribute, that basically specifies that a variable, let's say with static or thread storage duration, will not have its destructor run. This is a very contentious topic to discuss because people have very strong feelings about those kind of things. But just, thinking standard or committee wise, but in practice, it's something that we've, I had some really good feedback on people that want it at the time that we proposed it. So yeah, it's that simple in the sense of just having an attribute that would allow you to do those kind of things. One question though is that there's this if you think about attributes in the C++ standard, there is this expectation that the attribute could be if you're not using the attribute, you're not changing the semantics of the program too much, or basically at all. But let's say that that's not exactly true. So yeah, to get that into the standard, I think it's going to require a bit more of convincing, but because that's one of concern, right? The idea is that if you're having this kind of attribute being put, then you're gonna, let's say, something that had a destructor that could assert or to have any other side effect in your program won't have anymore because you're not required to emit it. So that's definitely, it's a change in semantics. But the idea, the core idea is simple. It's more like, don't even generate the destructor if no one else is using it. That could be some code saving as well there. But I guess more of also not messing up with the order where those things run.
I would definitely fall in the camp of people that says that sounds like a terrible idea because well-defined object lifetime is C++. But I can also appreciate the arguments for people who say, no, really, this object, I don't care what happens to it on destruction. Just let it free or when the on-program exit.
Right, yeah. I can definitely see the point about on the realms of tier down ordering kind of thing. Especially if you're maintaining a large piece of software, might have interesting side effects of changing that kind of thing under the hood. But yeah,
it seems like it should not be allowed on thread local objects.
That's also a very interesting perspective.
So what's the status of the paper currently then?
Yeah.
It's kind of on hold. One of the authors need to move with it. Let's see. We haven't discussed it ever since again.
Okay.
Maybe we need to push it a bit more for the next cycle.
At least get more feedback on it.
Yeah.
You were also working with the pattern matching paper writers?
Right. I haven't been there from the beginning, but 3 or 4 months ago, I started a new branch and I started putting support into Clang for the current proposal. It's still very early stage, but I think it's going to be really helpful and useful for kind of bulletproofing all the ideas and all the changes that are going to go through that paper, especially because there's been this, it should be a state pattern, with pattern matching, you have this inspect thing, which will be comparable to switch, right? Like a switch on steroids. That's how I like to look at it. And there's a desire that thing can be an expression, but it could also be used as a statement. And there's multiple discussions around that. So having a prototype and being able to evaluate this early, I think it's going to be really useful for at least ruling out a bunch of things that we hear or concerns that we hear that might be true, or even things that we are going to find out that okay, we can't actually parse this as we thought we would be able to, because there's this and that caveat for this other feature that we're gonna have a bit of trouble. So yeah, I'm really excited to see pattern matching happen, and I think I can help somewhat with the compiler part of the work.
What kinds of things would pattern matching allow that right now are either impossible or extremely difficult in C++?
Right. The way I see it, at least, maybe the original authors will have more rationale to put here, but my way to see that is that it's not about performance, but about allowing the C++ programmer to actually express more things easily. So, for example, since we were talking about embedded things, if you're writing an emulator, right? Or if you're trying to write a decoder for a processor or anything like that, it's usually, let's say it's a complex machine and you don't really have your opcodes when you're going to switch on that opcode, so you can catch the sub opcodes or things like that. You're not getting a byte, let's say you need some bits from this part of a byte and another bit from another part of the byte. You get different in a 4 bytes instruction, you're getting different bits from different parts so you can match the right thing. You cannot write a flat switch with all the things and they are going to look nice, Sometimes you want to say, well, if you see you have this opcode. If you're matched this number here, you're fine. But then you can do extra testings on top of that to actually get into that case. So with pattern matching, let's say you do inspect, and then once you're inspecting that value, you can do additional things just to say, well, turns out that I'm not a really good fit. Just look into the next one now, because you can have like on the case if you're comparing to a switch, right? On the case part, you can actually have a pattern guard that does an extra checking on top of what you're trying to match. So, and if that doesn't match, you could go to the next one. But if that matches, then you have like, you can bring on a new scope and actually write things on that scope. So I think for like expressiveness of like things like that, where you want to be able to, write more with the example of the decoder, for example, lots of examples used. Yeah, you can definitely be more expressive. I was playing with the decoder for Motorola 68K as we were previously discussing, and I was like, we need to see pattern matching happen soon, because I would really like to use this here. But yeah, that's the way I see it. I think it's pretty handy for being really clear on what you mean while you're going through switch, especially if it's a complicated one. And of course, like you have all this is just like my low-level intake, but it's going to be way more powerful than a switch, right? Because you could inspect on a type. You could also inspect on like tuples and like all the things that are kind of like more recent to C++. And the idea is that the pattern match will help you out express using all those new things. And I think that's pretty cool. Also, like it's all const_expr proof. So you could like theoretically like write a very simple switch-like thing, but that is completely const_expr, for instance, if everything is const_expr.
We like const_expr.
I love it too.
Okay.
I'm kind of curious, since we've just been talking so much about hardware and instruction sets and all these things, just like, is there anything that you think C++ programmers should be thinking about when programming that relates to how the compiler is going to generate our code? Or do you think we should just mostly just let the compiler do its job? Or like, do you have any advice from the work that you've done?
I think if you're doing like more close to bare metal work, I would say I don't think there's a lot extra things you should care about. Of course, like you should know that there's O2 and OZ, and that OZ is gonna like kind of like, at least in Clang, right? Like take a deeper care about your code size and things like that. But what I would advise though is like try to check what code gets generated for the things you really care. I'm not a big believer of early optimization. I think like you write your things, and then if you're writing code thinking about like testing your code and doing all the due diligence around it, it should become obvious like which parts need more care, and then you go to those parts, and then you might want to look into using specific attributes to kind of force some behaviors and things like that. Like you probably want to pack a few structs. Right, like you're gonna probably want to make some. If depending on how much memory you have, you might like want to be able to inline some things, and some of those things the compiler might not be able to figure out himself. So you gotta like give it extra clues. But yeah, I would like look into first getting like just make sure you're writing good C++ code that other people can understand first.
Okay,
and then. If that's not enough, you go to the specific parts, and then you look at things that people usually use in embedded, like things like packing structs and using other attributes to guarantee some of the semantics. Be really careful with volatile and all those things. Yeah.
Awesome.
Okay. Well, it's been great having you on the show today, Bruno. Is there anything else you want to share with our listeners before we let you go?
I know it was a great pleasure to talk with you, Jason, you, Rob. Like I'm a big fan of the podcast, and I think you guys are doing amazing work. Please keep doing it. Don't stop doing it. It's pretty cool.
Thank you very much.
Awesome. Thank you. Thanks so much for listening in as we chat about C++. We'd love to hear what you think of the podcast. Please let us know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, we'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. We'd also appreciate if you can like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at Lefticus on Twitter. We'd also like to thank all our patrons who help support the show through Patreon. If you'd like to support us on Patreon, you can do so at patreon.com/CppCast. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode was provided by podcastthemes.com.
That relates to how the compiler is going to generate our code, or do you think we should just mostly just let the compiler do its job, or do you have any advice from the work that you've done?
I think if you're doing like more close to bare metal work, I would say I don't think there's a lot extra things you should care about. Of course, you should know that there's O2 and OZ, and that OZ is gonna at least in Clang, right? Take a deeper care about your code size and things like that. But what I would advise though is try to check what code gets generated for the things you really care. I'm not a big believer of early optimization. I think you write your things, and then if you're writing code thinking about testing your code and doing all the due diligence around it, it should become obvious which parts need more care, and then you go to those parts, and then you might want to look into using specific attributes to kind of force some behaviors and things like that. You probably want to pack a few structs, right? You're gonna probably want to make some, if depending on how much memory you have, you might want to be able to inline some things, and some of those things the compiler might not be able to figure out himself, so you gotta give it extra clues. But yeah, I would look into first getting just make sure you're writing good C++ code that other people can understand first.
Okay.
And then if that's not enough, you go to the specific parts, and then you look at things that people usually use in embedded, things like packing structs and using other attributes to guarantee some of the semantics. Be really careful with volatile and all those things. Yeah.
Awesome.
Okay. Well, it's been great having you on the show today, Bruno. Is there anything else you want to share with our listeners before we let you go?
I know it was a great pleasure to talk with you, Jason, you, Rob. I'm a big fan of the podcast, and I think you guys are doing amazing work. Please keep doing it. Don't stop doing it. It's pretty cool.
Thank you very much.
Awesome. Thank you. Thanks so much for listening in as we chat about C++. We'd love to hear what you think of the podcast. Please let us know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, we'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. We'd also appreciate if you can like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at Lefticus on Twitter. We'd also like to thank all our patrons who help support the show through Patreon. If you'd like to support us on Patreon, you can do so at patreon.com/CppCast. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode was provided by podcastthemes.com. This episode was provided by podcastthemes.com.